Assalamu alaikum, my dear students. Today in this video lecture we will be solving some of the numericals based on electricity. The first numerical here, which is written on the board, is in the circuit below. This is the circuit. Calculate the combined resistance. You have to calculate the combined resistance here flowing through the circuit, the current flowing through the circuit, and you have to also calculate the current. Okay, and third one, the potential difference across 2 ohm resistor and 3 ohm resistor. Okay, you have to calculate the potential difference here across 2 ohm resistor and across 3 ohm resistor. So let's now do. First, we will calculate the combined resistance. This is very easy because they are connected in series. They are connected end to end. Okay, they are connected end to end. For example, these are the ends. They are connected in series. Okay, so we know in series combination, net effective resistance R will be equal to R1 plus R2. Okay, R1 plus R2. So it is 2 ohm plus 3 ohm, which is 5 ohm. This is net effective resistance. And secondly, the current flowing through the circuit. And to calculate the current. Okay, we know from Ohm's law. Okay, from Ohm's law, V is equal to IR. Okay, V is equal to IR. V is equal to IR. Or we can say I is equal to V by R. I is equal to V by R from this equation. So current will be here, V is given 12 volt divided by R is given, okay, 5 ohm. So 12 divided by 5 will be equal to 2.5 ampere. Okay, this ampere is the unit of current. And C part is the potential difference across 2 ohm and 3 ohm resistor. So let it be V1 here, the potential difference, and let it be V2 here, potential difference here. Okay, across R1 and across R2. So we know that this net potential difference, V is equal to V1 plus V2. Okay, this is net potential difference. Or I can say that this V1 is equal to IR1. Okay, from this equation, V1 is equal to IR1 because current here is same I. Okay, current here is same. For example, this is current I. This is same throughout this circuit. So resistance is different. So V1 will be equal to current is how much is current? 2.4 ampere multiplied by R1 is 2. So this is equal to 4.8 volt. Okay, 4.8 volt. And similarly, V2 will be equal to I R2, which is equal to I is 2.4 multiplied by R2 is 3. Okay, so this is equal to 7.2 volt. Here is the second question. In the circuit diagram given below, this is the diagram here. 3 resistors R1, R2 and R3 of 5 ohm, 10 ohm and 30 ohm respectively are connected as shown. So as you can see here, this is clear that they are connected in parallel. Okay, this is the parallel combination. So calculate, we have to calculate the current through each resistor. We have to calculate the current flowing through this resistor and flowing through this resistor and this resistor. And B part, total current in the circuit. We have to calculate the total current in the circuit and total resistance in the circuit, and then total resistance in the circuit. So we know that the resistance R1, R2 and R3 are connected in parallel. Okay, and if I1 current is flowing through this resistor and I2 current is flowing through this resistor, for example, this here it is current I1, here it is I2, and here it is I3, and here it is I. Okay, so we can calculate the current here. So I should write that I1, according to Ohm's law, current is equal to V by R. Okay, so I1 will be equal to V. Potential difference is same because in parallel combination, potential difference across the ends are same. So it is V divided by R1. Potential difference is same here. So as you can see here, this potential difference is 12 volt. Okay, so it is 12 volt divided by R1 is 5 ohm. Okay, so this is 2.4 ampere. So I1 is 2.4 ampere, and similarly I2 here is V by R2. V by R2, and V is 12 volt divided by R2 is 10 ohm. So 10 by 12, it is 1.2 ampere. Similarly, V by R3, 12 divided by 30 is equal to 0.4 ampere. So I1 is 2.4 ampere, I2 is 1.2 ampere, and I3 is 0.4 ampere. So now total current in the circuit, we have to calculate the total current, and we know that total current I is equal to I1 plus I2 plus I3. Okay, so total current I is equal to I1 plus I2 I3, which is equal to 2.4, 1.2, 0.4 is equal to 4 ampere. So total current is 4 ampere. Now let's calculate total resistance. Total resistance in parallel combination, we know that is equal to 1 by R equal to 1 by R1, 1 by R2 plus 1 by R3. This is the net effective resistance in parallel combination. So 1 by R1 is 1 by 5, R2 is 10, R3 is 30. So when I calculate this, this is equal to 1 by 3. Okay, so 1 by R is 1 by 3. So R is equal to 3 ohm. R is equal to 3 ohm. Because 1 by R is equal to 1 by 3, so R is equal to 3 ohm. This is the net effective resistance. Now here is another question, but this question is little bit different from those two questions. The question is calculate the resistance of the circuit shown in the figure below. So this is the figure, and this is R1, this is R2, and this is R3. But you can see here the combination here is a mixed type. Okay, these two R1 and R3 resistors are connected in series with this resistor R1. Okay, but R2 and R3 are connected in parallel to each other. How to solve these problems where there are mixed type of combinations? So let's try this question. Firstly, we will calculate this resistance. Okay, this combination resistance. So if R dash is the net effective resistance of these two combined resistors, two parallel combination resistors, for example, R dash is the net effective resistance. Okay, this is R dash. R dash is the net effective resistance of parallel combinations of R2 and R3. And we know that in parallel combination, net effective resistance 1 by R dash is equal to 1 by R2 here plus 1 by R3. Okay, so this is equal to 1 by R dash is equal to 1 by 4 plus 1 by 12. When I calculate this, I get 1 by 3. So R dash is equal to 3 ohm. So R dash is 3 ohm. Okay, and now here I will draw the another circuit which will be like this. Here it is R1, which is 6 ohm, and here the net effective resistance is 3 ohm. So I can connect here the net effective resistance like this. Okay, let this be R dash, and R dash is 3 ohm. So now they are connected in series. This is A, and this was B, and here, for example, I connected this with a battery. So this circuit becomes like this. So they are connected in series. So now I can calculate this resistance. So now R1 and R dash are in series. R1 and R dash are in series. So net effective resistance, for example, if net effective resistance is R, capital R, okay, so net effective resistance is R1 plus R dash. So R1 is 6 ohm here, 6 ohm plus 3 ohm, which is equal to 9 ohm. So net effective resistance in this circuit is 9 ohm. Here's another question. Find the effective resistance of the combination given below. This is the combination, the circuit diagram. Here it is R1 equal to 0.5 ohm resistance. R2 is 3.5 ohm resistance. R3 is 8.5 ohm resistance. R4 is 2.5 ohm resistance. So current enters here and leaves from here. As you can see that current enters from here and it goes this way and this way. Okay, current goes this way and this way. So here the current splits up. For example, here current here is I1 and here it's I2. So this I2 current flows from this and leaves from here. And similarly, I1 current flows from these two resistance and leaves from here. You can easily observe that these two resistors are connected in series. Okay, as they are connected end to end, this is the connection, end to end connection, and these two resistors are connected in series to each other. R1 and R4 are in series, R2 and R3 are in series combination. So I can write that R2 and R3 are in series. Similarly, R1 and R4 are in series, means are connected in series. Okay, so I can calculate R2 and R3 net effective resistance. For example, if R dash is the net effective resistance of R1 and R4, so R dash is R1 plus R4, which is equal to 0.5 plus 2.5 is equal to 3 ohm. So this is 3 ohm. And for example, R dash dash is the net effective resistance of these R2 and R3 resistances. So they are connected in series, therefore R dash dash is equal to R2 plus 3. Okay, so this is 3.5 ohm plus 8.5 ohm. This is equal to 12 ohm. Okay, so now the circuit will be like this. These two and these two when combined together, so R dash and R double dash are connected in parallel. Okay, they are connected in parallel. So the next diagram will be like this. Rub this. So the next diagram will be like this. Okay, so here it is current I1. It will be net current I here. Okay, so here it is resistance R dash, and here it is R double dash, and R dash is 3 ohm. It is 3 ohm here, and R double dash is 12 ohm. Okay, so now we can calculate the net effective resistance of this circuit. So I can calculate the net effective resistance. For example, if R is a net effective resistance, therefore net effective resistance R is equal to, because they are combined in parallel, so therefore 1 by R will be equal to 1 by R dash plus 1 by R double dash. This is equal to 1 by 3 ohm plus 1 by 12 ohm. So when I calculate this, I will get 15 by 36. So R is equal to 36 by 15, which will be equal to 2.4 ampere ohm. Okay, 2.4 ohm. So net resistance is equal to 2.4 ohm. So this is how we can solve these problems very easily. You can practice many more questions as given in your textbooks or in the references, and if you practice more questions, you will get hold on these problems. So it's well said that practice makes a man perfect. You have to practice more and more numericals so that you can get hold of it. Thank you.